We'll be looking at page 251, lesson 5-6, quotient property of radicals. So if we're looking at a radical that has a quotient underneath of it, such as the square root, open fraction 49, over 9, closed fraction, closed square root. So basically we have a fraction underneath the radical sign. How do we do with this? Looking at 49 over 9, we can see that those are both perfect squares. So we can rewrite this as a fraction with two radicals. What that would look like would be open fraction, open square root 49 over open square root 9, then closed fraction. So we need to take the square root of each piece. So first we take the square root of our numerator, which is the square root of 49. Square root of 49 is 7. So our numerator now becomes 7, and that's over the radical 9. What's the square root of 9? Which is 3. So then we end up with a new fraction of 7 over 3, because we took the square root of our numerator, took the square root of our denominator, and that becomes our answer. So now, what if it's not a perfect square? What if we have something like this open fraction, square root of 27, over square root of 3 closed fraction? Okay, so neither of these are perfect squares, but we can actually look at what's under the radicand first. So we can rewrite this as open square root, open fraction, 27 over 3 closed fraction, closed square root. And we can actually do the division first. And you don't have to rewrite it as with the radical over the whole fraction. It's just a way to look at it. So now we have 27 over 3 under the radical sign. So let's do that division first. 27 over 3. Well, that's the same thing as 9. 27 divided by 3 is 9. But we haven't taken the square root of it. So now what we have is the square root of 9, because we did the division 27 divided by 3. And we all know the square root of 9 is 3. So we can say open fraction, open radical 27 over open radical 3, close radical close fraction, equals 3. Or the square root of 27 divided by the square root of 3 equals 3. Okay, now let's talk about simplifying. Simplifying radical expressions. Okay, what are the rules? So the index number, remember the index, that's basically what the root is. The index number, or n, so the index n, is as small as possible. We want it to be as small as possible when we're simplifying. Okay, so we want that index number to be small. Second, the radicand contains no factors greater other than 1 that are the nth powers of an integer or a polynomial. We want the radicand, that's what's underneath our radical sign, has no factors other than 1 that are the nth power, of an integer. So what does that actually mean? Okay, anything over 2, anything over 1, anything 2 or over can be factored out and have the radical taken out of it. Okay, next step. The radicand has no fractions. So when you're simplifying it, you cannot leave it with any fractions. And lastly, no radicals in the denominator. Let me just recap. First, the index number, what you're taking the radical, what level your radical is, has to be as small as possible. The radicand has no factors that are the nth power of an integer, meaning anything pretty much over 1. The radicand has no fractions in it, and there's no radicals in your denominator. Those are the rules for simplifying radical expressions. Okay. So now let's look at some of these. The first thing we're going to talk about is rationalizing the denominator. So what does that mean? To rationalize the denominator, you have to multiply the numerator and the denominator by a quantity so that the radicand has an exact root. So let's look at some examples and what that means. So we're on page 251, and this is example 2. So we have the square root of the fraction x to the 4th over x to the 5th. Okay, the first thing we have to do is looking at it using the quotient property, because we have a fraction, so we need to take the numerator. So we have to take the square root of the numerator, so we have to take the square root of x to the 4th, and then we also have to take the square root of our denominator, which is x to the 5th. So let's factor it into squares. Factoring into squares, what does that mean? So the numerator becomes square root of x to the 2nd times x to the 2nd squared, which is the same thing as x to the 2nd times x to the 2nd. The denominator becomes y to the 2nd squared, because that's y to the 4th times y. Okay, so now let's take the square root of our squares in the numerator. X to the 2nd squared, that leaves us with just x squared on our numerator. And our denominator, we have y squared to the 2nd times y. Well, y squared to the 2nd comes out of the radical, and we're left with y squared. But this last y gets left in the square root side because it doesn't have a pair. So now we have a fraction of x squared over y squared times the square root of y. And one of the rules was you cannot leave a radical in your denominator. So how do we get rid of that? We rationalize it by multiplying the numerator and the denominator by the square root of y. So what that looks like is x squared times the square root of y over y squared times the square root of y times the square root of y. And the square root of y times the square root of y is the same thing as the square root of y squared. It becomes just y, because y squared, take the square root of that, and you're left with just y. So then your denominator, your numerator is still x squared, the square root of y, over y to the 3rd, because you have x squared times, or y squared times y. So you have x squared times the square root of y over y to the 3rd. And that takes all the radicals out of the denominator. Alright, let's look at another one. And this is still on page 251. And we have the fifth root of the fraction 5 over 4a, closed fraction. Okay, how do we do this? We have now the fifth root of 5 as our numerator, and the fifth root of 4a as our denominator. So now we need to rationalize our denominator. So we can't leave this fifth root of 4a, and there's no real fifth root of 4a. So what we do is rationalize it. And to do that, we multiply our numerator and denominator by something that would give us fifth roots. Fifth root of 4, how do we do that? Well, if we multiply it by 8, we get 32, and 2 to the 5th power is 32. So, we can multiply our numerator and our denominator by that fifth root of a. 8, that takes care of our numbers, but we have this a also in the denominator. And we need to get it up to a 5th power, so we multiply that by a to the 4th. So the rationalizing the denominator would look like our original expression, fifth root of 5 over fifth root of 4a times a numerator of fifth root of 8a to the 4th over fifth root of 8a to the 4th. And what does this equal? This equals, multiply our numerators across, and we get fifth root of 32a to the 5th, or a to the 4th, excuse me. So our numerator is fifth root of 32a to the 4th over Okay, I'm going to back up for a minute. So let's multiply our numerators again. Fifth root of 5 times the fifth root of a to the 4th gives us fifth root of 40a to the 4th over fifth root of 4a times the fifth root of 8a to the 4th gives us fifth root of 32a to the 5th. And if we're to take the fifth root of our denominator, which is 32a to the 5th, what we end up with is a numerator that stays the same, fifth root of 40a to the 4th over 2a. And the 2a is 32 if you break that into a fifth root. 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, is 32. So we take the fifth root of that and we get 2. And a to the 5th, you take the fifth root of a to the 5th and you're left with just a. So now we have a fraction with no radicals in the denominator.